Hey guys, welcome to my channel. I'm LeetCode. If you guys are new here, I pretty much do LeetCode style questions and explain things in the simplest way possible. Today we have an amazing problem for you guys, so I'm pretty excited about it. So let's go ahead and read the problem statement, guys. So the question is called given maximum depth of an N-ary tree, right? So N-ary tree, guys, it's a tree, it's a type of tree. I'm saying it's like binary trees that we have and stuff like that, right? In the binary tree, we had 0, 1, or 2 children, right? But this one can have many children, right? You can see we have 3 in this case. We have 2 here. We can have 5. We can have 6. No, we can have whatever. You know what I'm saying it's still the same property that every node has one parent. You know what I'm saying so. Same thing. Let's see. Can get very complex. You got 2 children here. You got 1. Yeah, it's you got 4 here, right? I'm saying you can have as many children as you want, right? Which is pretty good, guys. So this is our first problem that we're doing on N-ary tree on this channel. So this should be fun, right? It's an easy problem. So yeah, here says given an N-ary tree, right? Find its maximum depth, right? The maximum depth is the number of nodes along the path from root node down to the farthest leaf node, right? It says N-ary tree input serialization is represented in their level of traversal. Each group of children is separated by the null value. Okay, that's interesting. Okay. All right, so guys, what can we do? What can we do, man? So what's gonna be? So what we're gonna? So pretty much this example right here, right? We're given this N-ary tree, and the longest, the maximum depth, right, is gonna be 135 or 136, right? So you can see the maximum is gonna be um 1, right? It's gonna be 3 actually. I have to say 3, 1, 2, 3, or 135, right? That's the maximum depth. Right? It says starting from the root to the farthest leaf node. I'm saying the 2 furthest leaf node, right? Is 5 and 6, right? So that's why we're able to get the length of 3, guys. So this example, right? The longest path starting from the root to the furthest leaf node is gonna be this one, right? Visually looking at it, we see that, right? We see 1, 2, 3, 4, 5, guys, 5 nodes that make up that path, guys. So this is a very important, guys. So yeah, this is pretty doable. So we've done other problems just like this one on this channel already. So if you guys haven't seen it, something's gonna pop up. So this problem that I'm referring to is the maximum depth of a binary tree. We've done this problem before, so we're already comfortable with you doing it with a binary tree where every node calculates their maximum um, depth at their level, and then they do +1 to account for the node themselves, right? You know what I'm saying to account for that for yourself, right? And then you send that answer back to your parent, right? That called upon you, right? And then they themselves, the parent as well, right, does the same thing, right? Calculates the maximum and returns it to the parent, and you get that chain of stuff, right? I'm saying it keeps going up the recursive call stack until we get our answer that we're gonna get starting from the root, right? So it needs to start from the root, and that's kind of yeah. So the root is gonna give us that answer. So it's gonna be pretty much the same approach, guys. So how we're gonna do that, it's gonna be very intuitive, guys. So let's do a quick walkthrough. Let me copy that problem, right? So yeah, guys. So the way that we're gonna do it, guys, is gonna be pretty intuitive, guys. So pretty much gonna be the same way as we did in that other problem, the binary tree problem, where we found the maximum depth, right? So pretty much at every level, we're gonna calculate their maximum, like, pretty much we're going to calculate the height, guys, at every node. Every node is going to calculate their height, right? And then we also are gonna, yeah, so by how we're gonna calculate the height is by obtaining the height of our um child node, right? I'm saying height of our children, right? We get the maximum 1, right? And we do +1 to account for the node itself, right? The current node that we're on itself, right? And then we send it back to our caller, right? You know what I'm saying? Our parents or whatever I'm saying. So we're gonna do a quick walkthrough, guys. So pretty much the 1 is the root node, right? So 1 is gonna visit, let's say visit the first children, right? I'm saying I told you guys we have many children, right? Can't have many children, right? Can't have 25, we have 6, whatever, I mean amount of children that it wants, right? So pretty much we're gonna visit 3 first, right? So we go here, right? Um, we go here, and then now we go to 5, right? So 5 is gonna calculate its height, right? So it goes left. I mean, uh, it sees that it has no children, right? You know what I'm saying? It has no children, no child, right? You know what I'm saying? So now, saying he has no child, right? So the maximum of a get, right? I'm saying is gonna be no child, right? Zero, right? Plus one, right? One. So its height is gonna be a height of one, right? So it's gonna send that back to our color, right? Which is three, called on five, right? So now from that perspective, right? So it's gonna be one, right? So now three is also gonna call the other child, right? Because we're gonna visit every children, guys. So it's very, very important, right? I'm saying so we go there, right? And then six is gonna do the same thing as five, right? It has no children, so it's gonna be zero plus one, right? We do plus one to account for that node itself, right? Of six that we have, right? So it needs to account for to be accounted for. So we return that. So one gets six return one to this one. So now three is gonna make a decision, right? Three is gonna have a variable guide that's gonna keep track of the maximum height of all of each children, right? So we only care about the maximum one guide because it's the same logic that we use in that banner tree one, right? We want the maximum one, right? So what I'm saying, because that's the one that's going to lead us in building up the longest depth possible away from the root, right? I'm saying the maximum depth, right? I'm saying this is the maximum distance from the root, guys. That's why we only store in the maximum path, right? I'm saying. So what's your height? Your height is no one. So height, oh, it got one from both sides, right? So now the maximum is going to be obviously one, right? So now three is going to return one plus one, right? One, the maximum from the children, right? I'm saying, which is a one plus one, right, to account for itself, guys, which is gives us a value of two. So it has a height of two. You know what I'm saying? So now one is gonna call on two, right? So two is gonna go there, right? And then we already know what's up. It's the same case as this one, right? So two is gonna say, okay, I got a height of one, and then four is gonna do the same thing. I got a height of one, right? So now we did all the nodes, right? So now one is gonna pretty much make a decision, right? One is gonna be like, cool, what's the maximum? I'm saying the maximum height of all of my um the maximum of all my children, right? I'm saying the maximum height, right? The maximum height is gonna be two, right? So now it's gonna be two, right? And then now one is gonna also return, right, to us the color, right? To the maximum height of like any of my children nodes, right? The maximum one, right? It's I only care about the maximum one, right? You know what I'm saying? Which is the deepest one, the deepest leaf node, right? That's, you know what I'm saying? Which is the path that contains the deepest leaf node, right? So it's gonna be two plus one, guys, to account for that node itself, to account for one, right? Which is very, very important, guys, right? So the plus one. So every one of them did plus one after they obtained the longest I'm saying the maximum height from, you know what I'm saying, from their children, right? And then do plus one to account for themselves, right? So that's how they were able to get a two, right? So um hopefully that kind of makes sense, guys. So let's go back and back to the code and start coding the algorithm, guys. So hopefully now it should be relatively straightforward, guys. So pretty much we're gonna be using a helper function, guys, to do that, guys. What I'm saying, we use a helper function a lot on this channel. That's why I'm keeping it consistent in our approach, guys, right? So everything is pretty much the same, guys. Everything is the same as the other ones, right? So node root, right? What I'm saying, so now what we're gonna do, guys, we're gonna loop through all of our children, right, for a particular root. So we're gonna be, so how's it gonna look like? It's gonna be node, so it's gonna be child, right? You know what I'm saying, and roots. So where are the child stored? Where are they at, guys? They're storing the children thing, right? You know what I'm saying, that's how we're able to. There, it's a list, right? So we pretty much could loop through all the lists of children by that level, right? So now we also said that we're going to calculate the max, guys. We need to keep track of the maximum one that we've seen so far, right? So the how it's going to look like, then we map that max, right? With the current max that we have, or um, the child that we just called upon, right? And then after we do all of that, guys, we are, the maximum is going to stay, you know what I'm saying? So if we encountered, so from one's perspective, right, it got two from three, right? So now the maximum is two, gets updated to two, right? But initially zero, right? And then now it visits two, right? And then two returns one, right? right? But even then, right, the maximum does not get updated because we are storing the maximum, right? Because it's gonna so because two is greater than one, right? So it's not gonna get updated. You know what I'm saying? And then now after we do all of that, guys, we just do the maximum we're able to obtain plus one to account for this node itself, guys, right? Okay. So you see if we get to that case, right, we get to five, right? Five. All right. Five has no children, right? So the size of the list of this will be empty, right? So the maximum will be zero, right? So it will be zero plus one, right? Which is the node five, right? To account for node five itself, right? And then we do plus one, guys. So as simple as that, guys. Press run code. Seems like we're in good shape, guys. Let's press submit. You know what I'm saying. All right. So yeah, so we need to worry about that case. I'm saying original, we return zero, right? So we should be good now. All right, nice guys. We passed all the test cases, guys. So if you guys appreciated this video, I'm saying please give it a like. If you guys are new here, make sure to subscribe to the channel because we'll be doing a lot of videos just like this one. So yeah, I want to thank you guys for watching, and I'll see you guys in the next one.